So in this video, we'll try to sketch the graph of the given function x minus ln x. And please recall that you can make use of something that you learned in the topic of differentiations. For example, you can use the sign table of f prime to get the behavior of the critical numbers. So let's do it together now. First of all, f of x is x minus ln x, right? And we can get the f prime of x, which is 1 minus 1 over x, and to get all the critical numbers, so we can make it 0 and we can solve it. The next equation is 1 equals 1 over x, which means x equals 1 is actually a critical number. And you may be wondering if you can get some other critical numbers by making f prime undefined. So f prime is undefined when the denominator of 1 over x is 0. However, x equals 0 is not in the domain of the function, right? Because please look at the function x minus ln x. When x is 0, ln 0 is not defined at all. So it is not in the domain. So we don't have to look at the points where they are not in domain. So the next step is for the sign table of f prime. So let's do it together. Because we have only one critical number and the domain contains all the points x bigger than 0, because if x is 0 or less, these are not the points well defined on the function ln x. And anyway, on the sign table of f prime, there are actually two intervals now. You are required to choose one point in each interval. For example, you can choose maybe 0.5 in this first interval, and you can compute f prime of 0.5. So the answer is a negative value, and we can mark it as negative. Negative means we expect that the graph is actually decreasing, the line is decreasing, the tangent direction is going down. And similarly, we can choose the point maybe 2. Then we can do the f prime of 2, which is 1 minus 1 over 2, which is actually a positive value, which means the line is actually positive from there. So that's pretty much the sign table of the f prime. Anyway, it basically means that around point 1, you see, you're going down first and then going up. It means that the point 1 comma f of 1 is actually a local minimum, right? And f of 1 is the same as 1 minus ln 1, which is 1 minus 0, which is 1. So it means this point is actually 1 and 1. We expect that at 1 and 1, it is a local minimum. And let's see whether the sign table of the second derivative can give us further information. So you see the first derivative is 1 minus 1 over x. So the second derivative is b minus 1 over x squared, 1 over, which is positive 1 over x squared. And if you do the sign table here, it doesn't look very interesting, because you see the point is this one is not equal to 0 for all x, which means that if you look at the sign table of f prime, there's no critical number at all, so we only look at one interval. And the fact is that when f double prime is 1 over x squared, it's always positive, always. So it gives you a sense that for all the values of x in the domain, the f double prime is always positive. It means the shape of the graph of the y equals f of x is gonna be concave upward all time. So let's combine the two graphs for the sign table of f prime and f double prime together. These are the two sign tables of the first derivative and the second derivative. Let's combine all the information together. We don't have to look at the x values 0 or less. And we have one local minimum, as we noted before. The local minimum is 1, 1. We expect it's a local minimum, which means the behavior around this point is like this. And actually, you see, before 1, it is always decreasing, and it is going up after 1. So I'm using the derivative of the first table, first derivative test to get this, which means we can get something like this. And moreover, this shape actually fits in to our second table of the sign table of f double prime, because you see the shape is always concave up, and we actually obtain a concave up shape, essentially what we have on the first table. And that's pretty much what we have for this graph of y equals x minus ln of x.